Okay, this is from 7-2, and in this case we are finding the critical value with the confidence level. So let us go and look at how to do this and figure out even what we're doing here. Let me go down to this table over here, and this will be the first time you look at this table in this problem. I'll show you more in a bit. So this table, normally you would be looking at this right here and using this information over here. But this particular problem uses it in reverse. So you would be using what's over here to find out what's over here, which is why I'm going through this problem. So let's go back to it. And this is the example. So if you were to push the exam, show me an example in Course Compass, this is what you'd come up with. And so let's look at some things here. First of all, here's the confidence interval formula, which we'll be using to kick this thing off. And here's what you would go through. And it's relatively easy algebra. You substitute the 82% right here into the algebra, and you're solving for alpha. And from this step over to this step, you're removing the percent, and then from here you solve for alpha and you come up with 0.18. Okay, not too bad. And from here we're not quite done, because we need to really know what this thing is. Z of alpha over 2. Well, all we have is alpha at this point. So we need to substitute into here alpha over 2, which gives us 0.18 over 2. 0.18 over 2, dividing the 2 into the 0.18, we get 0.09. Okay, now we're at the point where we can look at this table here to come up with the answer. And before I get to that table, let's just look at what's in the textbook to explain what this thing right here is, this alpha over 2 stuff. And let me motor on down to the textbook page. And this is page 337. And here's what we're looking at right now, is this type of scenario. We've got a negative and a positive alpha over 2. However, there's this trickery down here, math trickery. The number alpha over 2 is a critical value, is a z-score with the property that it separates the area of alpha over 2 in the right tail. So we don't care about this in this problem. So you need to be aware of what that thing is. We're only after this one. Okay. So let's go back up here for a second. And once again, we've got z 0.09. And it's supposed to come up with 1.34. Well, there's two ways to do this. The first way is you go to the table, and we're looking at, excuse me, let me go back here. What are we looking at? We're looking at 0.09. Well, and one more time. Looking at 0.09 or 0.91 because we're looking at over here. So we look at through this thing and there it is. 0.9099. That's almost 0.91. So this would be 1.3, and you go up here and that's where you get the hundredths decimal point. So there yields the 1.34. Once again, this is 0.09. So here's our curve over here, and this is a crude drawing, obviously. And the alpha that we've calculated right here is this just to the right of this arrow. We need to actually figure out what is to the left of this arrow, and that would be 1 minus 0.09, which is equal to 0.91. And it's brutal writing this way. And that's what they're saying right here. So that's actually what we're looking for when we go to that table. So as I go down to the table to look at it again, here's 0.9099, which when you round to 2 decimals, 0.91, 1.34, and that's what the answer is. Lo and behold, 1.34. The other way, which is the calculator way so you don't have to go to the table, is one that, and I put it in here, inventory norm. How do you get this inventory norm of 0.91? You go to, turn on your calculator, second distribution, and there's inventory norm, 0.91, parentheses, enter, 1.34. And lo and behold, that is the answer. And on that, I think I've solved this problem, and I hope this helps you.